Good morning, good people. Thank you once again for your attendance, your patience. We are introducing you to mathematics Braille notation, IE 033. And so, as I said yesterday here, we are going to look at the computation of numbers, very, very key. And under the numbers, we'll look at, by the end of this unit, as a student, you should be able to, and as a teacher, your students should be able to read and write all numbers in Braille. They should be able to read and write basic mathematical operation signs in Braille. They should also be able to read and write fractions, decimals, and percentages in Braille. They should also be able to distinguish between the different mathematical brackets in Braille, and they should be able to compute operations involving all numbers using the abacus. And second last, they should be able to compute operations involving fractions and decimals using the abacus. Finally, they should be able to work out simple mathematical computations using the Taylor frame and algorithms. In this unit, we will look at 3 subsections and 3 areas. We will look at numbers and basic operations. We'll look at computations using abacus and also using algorithms and the Taylor frame. Under this section, we are looking at numbers and basic operations under section 1. And here we look at whole numbers. We will also look at basic operation signs. We'll look at fractions, decimals, decimal fractions, and percentages. At the same time, it's good that we first of all look at all numbers. And as you're aware, on our previous lessons, we say that dot 3 and 456, which is called a number sign or a numeral sign, should not start a Braille word, that is in English. But in mathematics, before we write a number, it must start with that numeral sign. Secondly, we say that we are forming numbers from A to J. So A to J, that is where we are going to form the numbers 1 to 9 and finally number 0. 0 is a number in mathematics Braille. So numeral sign precedes one or more of the letters A to J, and it shows that the signs that follow represent numbers. So for example, in writing number 1, we will have numeral sign dot 3 and 456, then dot 1, or that for letter A. So it's no longer going to be a letter, but now in this case, it's going to be number 1. Number 2 is going to be numeral sign, then letter B. Number 3 will be numeral sign, letter C. Number 4 will be numeral sign, letter D. Number 5 will be numeral sign, then letter E. That is dots representing that letter. Number 6 will be numeral sign, letter F. Number 7 will be numeral sign, letter G. Number 8 will be numeral sign, letter H. And number 9 will be numeral sign, letter I. And finally, 0, numeral sign, followed by dots for letter J. So for us to be able to write numbers, it is a rule and it's a must that in writing numbers, the numeral sign must come first before the number. Look at number 1. numeral sign dot 1. Number 2, numeral sign dot 1, 2. Number 3, numeral sign dot 1 and 4. Number 4, numeral sign dot 1 and 4, 5. Number 5 is numeral sign dot 1, 5. Number 6, numeral sign dot 1, 2, and 4. Number 7, numeral sign dot 1, 2, and 4, 5. Number 8 is numeral sign dot 2 and 4. Then number 0 is numeral sign dot 2 and 4, 5. It's what we call comma separator in mathematics. For example, when you want to write 2002, 145, that is 2145. The comma in mathematics is dot 3. Comma separator in mathematics when we are dealing with numeral sign, when we are dealing with numerals, symbols, the comma separator is dot 3. In writing numbers with more than 3 digits, dot 3 is used to represent the print comma dividing off the 1,000, and this rule applies only to figures. For example, as you're able to see, we have 4,500, which is written as numeral sign 4.3, then 500. We can also use that numeral sign, that comma, when we are dealing with a figure that has more than the hundreds. Like in this case, we have 275,250,000. So there are 2 commas after 5 and also after 0. So the comma in this case, we are going to use dot 3 as comma in mathematics Braille. It's good that we get to understand that in dealing with mathematics Braille, one must get to understand basic operation signs. Here we are going to learn about 5 basic operation signs in mathematics Braille. And the first basic operation sign is addition or plus sign. We'll look at subtraction or minus sign. We'll look at multiplication sign. We'll also look at the division sign. And finally, we have the equal sign. All these 5 are basic operation sign. They are all basic operation sign. Let's look at the first one, addition or plus. In addition, we are saying that addition sign, for us to be able to write a basic operation sign, we must precede all basic operation signs with .56. Something that we also call a letter sign. We will talk about letter sign deeply when we'll be talking about algebraic expressions, where we'll be having symbols and with the letters. We'll talk about this. We'll talk about that one later. But of most importance is that each and every basic operation sign must be preceded by .5 and .6. And so in this case, addition sign is .56 followed by lower f. So .56 lower f is addition sign. Subtraction sign is .56 bottom C. Remember that we said for letter C, there is no lower C. It's either it is letter C, middle C, or bottom C. In multiplication sign, we have dot 56 lower h. Dot 56 followed by lower h. We have division sign, which is dot 56 followed by lower d. Dot 56 followed by lower d is for division sign. And then we have equal sign, which is dot 56 lower g. We have a formula to help us remember this. That is, faith come here, don't go. Faith come here, don't go. As you're able to see, we have the first letters of our formula in red. After they have been preceded by dot 56, they must have lower letters. That is dot 56 lower f, dot 56 bottom c, dot 56 lower h, dot 56 lower d, and finally dot 56 lower g, in that order. So we have the addition sign, the subtraction sign, the multiplication sign, the division sign, the equal sign, and of course the equal sign is the last one. What are the rules? Braille is a home of rules, very simple rules that help us to remain within the parameters and within what is required. The first basic rule governing the use of this basic operation sign is that each basic operation sign must be preceded by a letter sign dot 56. It is a must that each basic operation sign be preceded by dot 56. Number two, we are also saying that all basic operations are written spaced from what precedes them. As you'll be able to see. And number three is that all basic operation signs are written adjoined. They are written adjoined to whatever they precede. And finally, that all basic operation signs must be lowered except subtraction, which is bottom C. The fourth rule is that all basic operation signs must be lowered except subtraction, which is bottom C. Now, of course, having mentioned that, it's good that we take note. It's good to take note of the same. I want to take you to some few examples here. You can be able to see we have 4 plus 2 equals 6. And we are saying the first rule is that you realize that for us to write a number, the number must be preceded by a numeral sign. But the first rule was each basic operation sign must be preceded by a letter sign. So we have numeral sign, then the dots for letter D to mean 4. Then the first rule is saying each basic operation sign must be followed by a letter sign. So allow me to teach rule 2, then I'll teach rule 1. Rule 2 was that all basic operations are written spaced from what precedes them. So we have 4 4 must be spaced. 4, then we space the basic operation sign, that is addition sign, which is 0.56 lower f. 0.56 lower f is addition sign. And rule 2 was saying all basic operation signs must be written space from what precedes them. Whatever that comes before them, they must be written space. So 4 space 0.56 lower f. Rule number 1 was each basic operation sign must be preceded by 0.56. So now 0.56 lower f for addition. Then for us to write the 2 again, because it is 4 plus 2, for us to write the 2, we put a numeral sign, then 2. Remember that our rule number 3 was saying that all basic operation signs must be written adjoint. All basic operation signs are written adjoint to whatever they precede. So here, addition comes before 2, so plus, then 2, plus 2. So the rule is we are going to write the addition sign and the 2 unspaced. We are adjoining whatever is coming after the basic operation sign. So 0.56 lower f for plus the numeral sign, then 2. Rule number 3, all basic operations are written adjoint to whatever they precede. So plus 2 is written unspaced. And again, we are going to space it because remember after plus 2 we have the equal sign. And that plus 2 is coming before the equal sign. So we are going to put a space, one space, and then we'll have 0.56 lower g for the equal sign. And then we are not going to space because 6 is coming after the equal sign. We are going to write the 6 adjoint to the equal sign such that it is going to be 0.56 lower g, the numeral sign f for 6. So we'll have written 2 space plus, 4 space plus 2, we adjoin space equals 6 adjoined together. So when your work is going to be marked, the marker will check, did you put a numeral sign before writing 4? Yes. Did you space before the addition sign? Yes. Did you write the addition and 2 adjoined together without space? Yes. Did you space before writing the equal sign? Yes. Did you put 0.56 before lower g? Yes. And did you write numeral sign before writing 6? Yes. And did you join the equal sign and 6 together? Yes. And so that is how we are supposed to deal with basic operation sign. We have the addition sign. As you're able to see here, the first one, we have 2 plus 3. Here we have 2 plus 3. And after that, we have, you can see here, we have the second one here. We have now 7 plus 4. Number 3, we have the third one here, we have 16 plus 216 plus 237. And the fourth one, we have 2002, 800. 2800 plus 300, plus 200, sorry, plus 200. And finally, we have 0, 0, 0.4 plus 39 plus 12 plus 23,444. Subtraction sign is written as dot 56 bottom C, just as I have just illustrated above. I want you to see now this one has certain arrows. These arrows you see here indicates the spaces. So the first one, we have 8 minus 6. The second one, we have 20 minus 5. Multiplication sign, 4 times 2, that is the red one. The blue one, 3 times 9, and the green one is 33 times 33. Division sign is written as dot 56 lower d. So the first one is 6 times 3. The second one is 12 times 4. How do we use equal sign, which is written dot 56 lower g? So I want you to look at this. We have numeral sign 6 space addition sign, numeral sign 4. So this is 6 plus 4 space dot 56 lower g for equal sign, numeral sign 1, 0. So the first one is 6 plus 4 equals 10. The second one is 7 plus 2 equals 9. And the third one is 86 minus 40 equals 50. And here we are not dealing with computations, like you must get the right answer. Here we are looking at the concept of converting, or concept of putting mathematics in Braille notations. We are not interested so much in the answer. So you'll meet a certain exercises reading 2 plus 4 is equals to 30. We are looking at your ability to debraille that correctly. So during your free time, I want you to try the slide you are able to see, that assignment, so that next time we will be able to look at the fractions and decimals. Otherwise, thank you very much for you taking your time to follow up with us during our introduction to Braille 3, Mathematics Braille Notation, and have a lovely day.